Hi, so today we'll be looking at another topic in chemistry. Basically, we'll be talking about alkenes. So, under these alkenes, we'll be looking at the structure, the properties, as well as the application. So, what do you stand to learn from this class? You'll be able to understand the structure of the alkenes, illustrate with structures, members of the alkene, understand nomenclature of the alkene, explain the laboratory preparation of alkenes, express the chemical properties of alkene, describe tests to distinguish alkanes and alkenes. Okay, so let's talk about the alkenes. Alkenes, they are unsaturated hydrocarbon. Now, what do we mean by unsaturated hydrocarbon? These are hydrocarbon with either double bond or triple bond. That is, they will have at least one or two double bond or triple bond in them. Now, if you look at your screen, you can see the double bond. This is actually a double bond, and this is a triple bond. So it simply means that what I have here is representing alkene. Okay. However, when we are talking about alkenes, alkenes, they are saturated hydrocarbon because they contain only a single bond. Okay, so we now say that alkenes are hydrocarbon with at least one carbon-carbon double bond. General formula is CnH2n. Now, with this general formula, you can determine the molecular formula of any of the alkenes. For instance, if you have to write the molecular formula for ethene. How do you get to write the molecular formula for ethene? What you just need to do is to use this formula, then you get the molecular formula of ethene. The N represents the number of carbon. So in this case of ethene, we know that ethene contains 2 carbon. So I need you to pause this video and try to attempt this. Determine the molecular formula of ethene. Okay, so your answer should give you C2H4. So it simply means that you put 2, you substitute 2 where we have the N. So this we have 2 times 2, which is 4, then we have 2 here, that's C2H4. So this can also be applicable to other members of the alkenes, that is the propane, the butane, and so on. Okay, I've talked about this, that unsaturated compounds. Example, ethane, propene. Now take a look at this. Why are alkenes considered as unsaturated hydrocarbon? You can quickly pause this video and give a response. Okay, consider this table. Look at this table. The table actually shows the molecular formula and the name of members of the ethene, of the alkene rather, of the alkene. So as you can see, ethene has 2 carbon and the molecular formula is C2H4. So it's good for you to study these charts to have a better understanding. Okay, so let's quickly talk about the sigma and pi bond. Now, looking at the structure we have here, we can easily determine the number of sigma bond and the number of pi bond. For instance, if you are asked to determine the number of sigma bond in this structure and the number of pi bond in this structure, how can you go about it? First, you should know that all single bond, they are sigma bond. So this is a single bond, this is a single bond, this is a single bond, this is a single bond. They are all sigma bond. Now, if we have a double bond, just like this and this, for every double bond, there is one sigma bond and one pi bond. So it simply means that in this double bond here, you will have one sigma bond, you will have one pi bond. Now, for triple bond, for every triple bond, you will have one sigma bond and two pi bonds. So the first bond here is a sigma bond, while these two bonds, they are pi bond. Now, can you now try this? How many sigma bond and pi bond are present in this molecule? Can you quickly try it? Okay, so there are 7 sigma bond in this molecule. There are 7 sigma bond in this molecule. Let's count. This is 1, 2, 3, 4, 5. We take one bond here, 6. Then we take another bond here, 7. Now let's count the pi bond. The pi bond now we have 1, 2, 3, and 4. So we have 7 sigma bond and 4 pi bonds. Okay? So you can see here we say that double bond consists of 1 sigma bond and 1 pi bond. Planar structure around the double bond angle approximately 120 degrees. So these are just trying to explain the structure of alkenes due to the positioning of the bonds. Now consider this. How many sigma bonds are How many sigma bonds and pi bonds are in the molecules below? So consider this molecule and this. How many sigma bond, how many pi bond are found in molecule A, molecule B, and C? So quickly pause this video and attempt this. Nomenclature of alkenes. So I believe you already know that when we are talking about nomenclature, it has to do with naming of alkene. So we have some rules for naming of alkenes, just like naming alkenes. There are rules governing the naming. First, we have identify the longest carbon chain containing the double bond. Number the chain from the end nearest the double bond. Use suffix "-ene" to indicate an alkene. Indicate the position of the double bond with a number. Now let's take a look at this. The first one says identify the longest carbon chain. The longest carbon chain represents, let me use number 3 as an instance. The longest carbon chain represents this CH2, C, and CH3. That contains 3 carbon. Now, if I'm to look at it from this angle, we have C and CH3. That's just 2 carbon. So my longest chain will be CH2, C, and CH3, not C, CH3. Okay? Number the chain from the end nearest the double bond. Now, looking at this double bond is just like it's centralized, so I can start my numbering anywhere. If I start from here, it's going to be same actually. So I can just have something like this. This to be carbon 1, this 2, and base 3. Okay, so and that's why we have it. You cannot say that use suffix in to indicate the alkene, indicate the position of the double bond. Now you can see that our double bond is at position 1. Now I know you might ask that, okay, but this double bond is also attached to carbon 2. Usually it's preferable to name that double bond to the lowest number, which is 1. So that's why we can now say that 2-methyl. Why do we call it 2-methyl? This methyl group here is at position 2. So 2-methyl, then 1-propene. Why do we call it 1? Because the double bond is at position 1. So then you cannot name it the parent, the straight chain, the longest chain, which is from the propane. So we can now say 2-methyl 1-propene. Now let's take a look at number 4. Can you identify the longest chain? So the longest chain will be this straight chain we have there. Now where do you think we are going to start our number from? Okay, in this case, you have to consider the position of the double bond. So if I start my numbering from, let's say, okay, let me do it this way. The right numbering should be from here, which is 1, 2, 3, 4, and 5. Now, why do I have to start from here? I'm starting from here because this double bond is closer to this carbon. It's wrong for me to start my numbering from here. So if I start numbering from here, like 1, 2, 3, then this is wrong. This is a wrong numbering. But this numbering here is correct. Now, why is it correct? Because this double bond is closer to this point. So that follows the rules that says number the chain from the end nearest the double bond. So now we can now name the compound. First, what is the position of the substituent group, this methyl? If we count from here, we have 1, 2, 3. So we can now say 3-methyl 1-propene. Please, this is actually propane, not propane. This is propane. Okay, so that's 3-methyl 1-propene. So I believe we understand how we arrive at that. Now let's take a look at it if we have to number from the right hand side. If we are numbering from the right hand side, what are we going to have? So this will be 1, 2, 3, 4, so, and 5. In that case, my naming will now become 3-methyl 4-propene, which is wrong. I can't have that naming. So the right naming is 3-methyl 1-propene. Okay, so I believe you understand this now, and you can try as much as possible to attempt more questions. Now draw the structure of 3-methyl pent 2-ene. 3-methyl pent 2-ene. Now note that the 2-ene tells you the position of the double bond. The second question says draw the structure of both 1,2-diene. both 1,2-diene. In that case, it tells you that there is going to be 2 double bonds in the structure. One will be in position 1 and the second will be in position 2. When you are drawing, remember that carbon is tetravalent and it can only contain 4 bonds attached to it. So please Okay, let's consider this question here too. You have two structures, structure A and structure B. You have to name structure A and structure B. So pause this video and try to name it. Okay, here you have your answer. Structure A is 3,4-dichloro, both 1E, both 1-ene, while structure B is 2-chlorobutane, 1,3-diene. You might want to review it again if you did not get it correctly. Preparation of alkenes. Alkenes can be prepared by dehydration of alcohols. Alcohols can be dehydrated to form alkenes. Requires an acid catalyst, for instance sulfuric acid, that we also call H2SO4 hydrogen tetrasulfate 6 acid. Example, ethanol to ethene. It simply means you can dehydrate ethanol to form ethene. When we mean dehydration, it's more or less like removing water from ethanol. So once you remove the water from the ethanol, what you will have left is going to be ethene. So the required acid for that process is the sulfuric acid. Okay, the process of this dehydration occur in stages actually. Now if you look at this, we have the stage 1, or what we call the step 1, which involve protonation of alcohol. In that stage, you can see this is the structure of alcohol, that is the ethanol. CH3, CH2, then OH. Okay, now what actually happened there is that the sulfuric acid provides the hydrogen ion for the dehydration reaction. Okay, let me use the pointer. So as you can see, this hydrogen ion we have here is being provided by the sulfuric acid. Okay, so now once the hydrogen ion is being provided, it is then combined with the ethanol to form this compound. So you can now see that in this compound we have here, we now have another hydrogen being added to the OH here. So the next step is formation of carbocation by loss of water. So this water, there is lots of water molecule from this compound here, so as you can see. Then finally, formation of ethene by loss of proton. So eventually, there is going to be loss of one hydrogen atom from the compound we have here. That is basically this hydrogen we have here. Let's say we are taking this off. So if we take this off, we'll now be left with C2H4. Okay, so and that's how we arrive at this. So basically we have been able to explain the preparation of alkenes from dehydration of alcohol. Question: why is an acid catalyst necessary for the dehydration of alcohol? So pause this video and try to think about your response. Answer: the acid catalyst helps to protonate the alcohol, making it a better leaving group and facilitate. Okay, so let's talk about preparation of alkane by the hydrogenation of alkyl halide. Now, when we say we want to prepare alkanes from the dehydrogenation, what it simply means that we are going to be removing water and halogen from an alkyl halide. Now let's take a look at this structure. In this structure we have here, this is bromoethane. Now if you look at this structure, this entire structure is what we refer to as the alkyl halide. Why do we call it the alkyl halide? Because it contains one halogen, which is bromine. So for us to carry out this reaction, we should have potassium hydroxide, that is this KOH. Then another condition required for this reaction is heat. Okay, now what happens is that the potassium will attack this bromine to form potassium bromide. So it simply means this potassium, that is this K, will attack the bromine, and that gives us the potassium bromide. Now the remaining hydroxide, which is OH, will now combine with H to form H2O. So we have seen that we have been able to remove water, and that's where the dehydro comes from, and the halogen, which is bromine, has also been removed. Okay, so now because of the removal of water and the halogen, that is the bromine, it's going to introduce a double bond into this structure, and that's how we now have ethane, which is an alkane. Okay, I hope you understand this preparation. So I would love you to pause this video and just try to show the preparation of alkanes based on the two methods we have discussed so far. It's very important for you to indicate structure, like this structure you are seeing. Learn drawing the structure without checking the screen. Okay, thank you. Now you should also take a look at this question as well. This is another critical thinking question. What role does the strong base play in the hydrogenation? So you can pause this video again and answer. So let's quickly look at the chemical properties of alkane. Okay, alkanes generally they undergo additional reaction. Now, one of the additional reactions that can be carried out by alkane is hydrogenation. That is, hydrogen can be added to alkane, and when hydrogen is added to alkane, it becomes an alkane. So, hydrogenation of an alkene will produce alkane. Okay, another one is going to be halogenation. So they can also be halogenated, that is addition of the halogen, for instance bromine and chlorine. We can also have hydrohalogenation, and we can also have hydration. Now when we are talking about hydration simply means the addition of water. Okay, now take a look at this general structure for the additional reaction of alkanes. So this has to do with halogenation, and you can see that bromine is being added. So upon the addition of bromine, the double bond is being reduced to single bond, so it becomes dibromoethane. Now for the hydration, that involves addition of water molecule. So upon the hydration, it forms ethanol. Okay, so you can add a question that will say that hydration of alkane will produce dash. just know that it's going to produce an ethanol. And the question could say that halogenation of alkane will produce dash. Know that the product is going to form an alkane. Now, if you want to be specific, you can now say that depending on the halogen that has been added, if it's bromine, then you might be thinking of dibromoethane. If it's chlorine, then you might be thinking of dichloroethane. Okay, so now in the case of hydrogenation too, it has to do with addition of 2 atoms of hydrogen, and that will give us ethane. So we also have the polymerization reaction. So talking about polymerization reaction, it has to do with addition of maybe 2 alkene together. For instance, you might want to combine 2 ethane. So addition of those ones can bring about polyvinyl chloride. Okay, so we are going to stop here for today. We'll continue in our next video. Alright, thank you. Take a look at this critical thinking question. Why are addition reaction characteristics of alkenes? Okay, here you have the answer. Okay, thank you. See you next class. Bye. Okay, so very quickly, let's talk about how we can test for alkanes and alkenes. For instance, if you have 2 solutions and they seems to be colorless, you don't know which one is alkanes, you don't know which one is alkenes. Let's see how we can test for this. So basically, we can differentiate between alkanes and alkenes using bromine water. Now, actually, the color of bromine water is like reddish brown. Now, if you add alkene, if you add alkene to bromine water, the bromine water will decolorize the alkene. Okay, so it will make it colorless. But if it's alkane, the color will not change. It simply means that the reddish brown will still remain the same. Now, if you look at the diagram here, this diagram here, you can see that in this case now we have the alkane still maintaining a reddish brown, while the alkane is colorless. So this happens upon addition of bromine water to the unknown sample. So with that, you can differentiate between alkenes and alkanes. Just know that alkenes will decolorize bromine water, and this is because alkenes, they have double bond. So addition of the bromine will reduce the double bond to single bond, thereby changing the color. Okay, but since alkenes, they don't have any double bond, so there won't be a reduction of any bond. Okay, so that's what we are saying here. We also have the Bayes test. Alkenes react with KMnO4, but alkenes do not. Okay, so let's have this critical thinking question. Why do alkenes react with bromine water? Why alkenes do not? So quickly pause this video and put down your response. You can try to listen again to get the explanation. Alright. So check your answer. So, real world applications of alkenes. Okay, we are using the production of polymers like polyethylene, polypropylene, They are also used in synthesis of chemicals such as ethanol, ethylene, and glycol. They are used in the manufacture of detergents and lubricants. Critical thinking question. How do the properties of alkenes make them suitable for polymer production? Okay. Now, basically, the double bond in alkenes allow them to undergo polymerization, forming long chains that are the basis of many synthetic materials. Okay, so that's a response for the question. Environmental impact of alkenes. Alkenes are precursors to many industrial chemicals, that is, they are basic starter for many industrial chemicals. That's what precursor means, starter. They can contribute to air pollution, for instance, ethylene in smoke formation. Biodegradable polymers reduce environmental impacts. So what do we mean by biodegradable polymers? Polymers that can be that we can break down using maybe microorganisms. Okay, attempt this question. What are the environmental concerns associated with the use of alkenes? So you can quickly pause this video and think of something to write. Check your response if it tallies to what you also add. Okay, if you are watching this as a group or in a class, you can quickly do this activity. Form group and shows an alkene. Research its properties, preparation, and applications. Presents findings to the class. So this final assessment, you can just quickly pause this video and attempt these questions. Then you check your. Okay, so this will be all for this lesson on alkene. Thank you. See you next class. Bye.